Welcome to the first lesson in the Earth atmosphere topic. This video is designed to help you get really good at your understanding of the Earth's atmosphere. You don't need to write down any answers until I tell you to later in the video. Okay, here's a starter activity. You don't need to write this down. Pause the video and think to yourself which letter matches which number. Pause it now. Let's go through the answers. A chemical made of one type of atom only is an element. A compound is made of more than one type of atom bonded together. A mixture can be easily separated. A reactant is a chemical used up in a reaction. A molecule is a small group of atoms bonded together. Chemical formula tells us the number and type of atoms in a chemical. A hydrocarbon is made of carbon and hydrogen bonded together. And a product is a chemical made as a result of a chemical reaction. Our driving question is, has Earth's atmosphere always been the same? We're going to be looking at the amounts of nitrogen, oxygen, argon, and carbon dioxide, and whether it has changed over time. Okay, imagine a space shuttle flying up through the Earth's atmosphere and out into space. What would it pass through? Well, the Earth's atmosphere extends up to around about 10,000 kilometers in the air, and it's made of air all of the way up: nitrogen, oxygen, argon, and carbon dioxide. But it gets thinner and thinner as you go up. The ozone layer is a section which happens to have a little bit more ozone than usual, but the atmosphere is made of air all of the way up. But it does get thinner and thinner until eventually there's no atmosphere left, and that's where we say the edge of outer space is. So the Earth's atmosphere does not have a clear boundary. It gradually gets thinner as it gets further from the surface. There's no specific end point, it just gets thinner and thinner until outer space begins. The atmosphere is made of a mixture of gases. 78%, roughly speaking, is nitrogen, around about 20% oxygen. Argon makes up about 1% of the atmosphere. Carbon dioxide, about 0.04% of the atmosphere. And the chemical formula of nitrogen is N2, oxygen is O2, argon is Ar, carbon dioxide is CO2, and then there's a tiny amount of helium and a variable amount of water vapor in the air. Air is a mixture of these chemicals. We call them molecules, small groups of atoms bonded together, apart from argon, which is single atoms only. For it to be a molecule, it has to be a small group of atoms that are bonded together. Let's have a look. Nitrogen molecules are N2 because there are two atoms of nitrogen in the molecule. Oxygen is O2 because there are two oxygens in the molecule. Carbon dioxide, CO2, one carbon and two oxygens. And then argon exists as single atoms. Sometimes we use the word monatomic, one atom only. Okay, carbon dioxide went very quickly there. Let's put it back. It's a really important one later in this topic for global warming and climate change. It's carbon dioxide, CO2. The 2 refers to oxygen. Carbon is 1. If there's no number next to an atom, that means 1. So CO2 means 1 carbon and 2 oxygens bonded together. The carbon is in the middle, the 2 oxygens bonded on the outside. Right, can you remember the answers to these questions? Right, you're doing this on a video, so pause it and think of the answers to these questions. And then when you've thought of the answers, press play again to see if you were right. Pause it now. Okay, memory test. How much can you remember? Nitrogen is N2. It is 78% of the Earth's atmosphere. Oxygen is O2. It is around 20% of the Earth's atmosphere. Argon is Ar, about 1% of the Earth's atmosphere. Carbon dioxide, CO2, about 0.04% of the Earth's atmosphere. Okay, now let's see. Has it always been the same? Well, we're going to look at a pie chart of what happened to the Earth in its older history. So let's have a think about pie charts. Why do we use pie charts for percentages? Well, a percentage will always add up to 100%. So we can use the full circle to represent 100%. Each slice of the pie is drawn to scale. That means that we can estimate which percentages are bigger and smaller visually by looking at the size of the slice of the pie. And because percentages will add up to 100, then all of the slices together will add up to a full circle. So pie charts are really good for percentages because percentages add up to 100% to make a full circle. Helps us to visually compare the size of each percentage by comparing the size of each slice. Okay, pause the video. Which is the wrong answer? Which is false? A, B, C, or D? 3 correct answers, 1 false answer. Pause the video, figure out which is false. Let's check the answers. C was false. So A is true. We can visually compare the size of each percentage. Each slice does represent a percentage out of 100%. D, 100%, yeah, it will add up to the total number for the whole circle, but it will not add up to 360. There are 360 degrees in a circle. You use that as part of the calculation to work out how big each angle should be in a pie chart, but the percentages will add up to 100%. Okay, right, now the Earth's atmosphere is 4.6 billion years old. In fact, the Earth is 4.6 billion years old. And we currently have these percentages: 78% nitrogen, 20% oxygen, 1% argon, 0.04% carbon dioxide. But for how much of the Earth's history has that been true? Well, it's the last 200 million years. Now, obviously, 200 million years is a very long time to us, but compared to the age of the Earth, 4.6 billion years old, is actually not that much. There's not that much of the Earth's history where we've had these percentages in the atmosphere. Now, this leads to the question, what was it like before then? What actually happened in the Earth's atmosphere before 200 million years ago? I mean, you can see just from this scale how close to the present day 200 million years ago is compared to the epic age of the whole entire Earth. Right? Now, the question is, before 200 million years ago, what was the Earth's atmosphere actually like? Okay, the Earth is very, very ancient, 4.6 billion years ago. So for all of that time, what was the Earth's atmosphere like? Well, the answer is a bit of a trick question. We don't really know. There is limited evidence as to what the Earth's atmosphere was like then, but we do have a theory. We do have an idea of what we think it is. And we think the Earth's atmosphere would have been similar to how Mars is now. Mars is also 4.6 billion years old, and life never developed on Mars. Mars has no oceans. We think that's what Earth was like billions of years ago. So the atmosphere of Mars now could be similar to the atmosphere of the Earth billions of years ago. So what is Mars like? Let's have a look. Mars only has 3% nitrogen, 1% oxygen, 1.6 argon, and 94.4% carbon dioxide. The atmosphere is mostly carbon dioxide, and we think this is probably what the Earth was like billions of years ago. Okay, so for 200 million years, it was 80% nitrogen, 20% oxygen, more or less. We think, even though we don't have much evidence, we think it was like Mars. We think Earth billions of years ago was like Mars is now. Why is there so little evidence for what Earth was like? Well, the way we find out about the atmosphere a long time ago is by looking at where gases have been dissolved in the ocean and frozen into ice, or maybe where they've been trapped in rocks. We can find rocks, and we can even find ice from thousands of years ago. We can find rocks from millions of years ago. But the rocks from millions of years ago and billions of years ago tend not to have many of the Earth's atmosphere gases trapped in them. The Earth's crust has changed too many times over billions of years. All the evidence from back then has been destroyed. If you think about, you might have learned in geography about tectonic plates moving around, the Earth's atmosphere does get the Earth's crust does get changed over billions of years, too much for us to be able to find a lot of evidence about the gases in the atmosphere. So, why do we use Mars as an example of what the Earth's early atmosphere might have been like? Pause the video and think of a sentence or two. Why do we use Mars as an example of what the Earth's early atmosphere might have been like? Pause it now. Let's look at the answer. Mars is about the same age as Earth. Life never developed on Mars. Mars has no oceans. We think that is similar to how Earth was billions of years ago. There is very little evidence on Earth from billions of years ago. Any gases that got trapped in rocks at that time can't be measured now. So we have limited evidence to what Earth was like billions of years ago. So instead we look at Mars because we think that Mars is physically similar to what Earth was like billions of years ago. Now, in the writing task, you are going to compare data of the Earth's atmosphere of that with Mars. This is a common exam question. Whenever you get the words use data in a science exam question, that means include the numbers from the graphs in your answers. If you don't include any numbers, you won't get any marks. So use data means include the numbers from the graphs in your answer. So for example, the percentage of oxygen on Earth and Mars is different. 0 marks. On Earth it is 20%, and on Mars it is only 1%. That gets a mark. You have to be that specific. You have to spell out what the numbers are. Okay, so a better answer is the percentage of oxygen on Earth and Mars is different. I know this because on Earth it is now 20% oxygen, whereas on Mars it is only 1% oxygen. Use the numbers. Okay, a second memory test. Can you remember this information from earlier in the video? It's appearing in the wrong order. Let's put all the questions on the screen. Pause the video. You don't have to write this down. Think to yourself, what are the answers to these questions? Pause it now. Okay, here we go. Let's have a look. Earth is 4.6 billion years old. The atmosphere has had these percentages for 200 million years. What are the current percentages? Nitrogen is N2, 78%. Oxygen is O2, 20%. Argon, AR, 1%. Carbon dioxide, CO2, 0.04%. Okay, it is time for the writing task. Now, this is where you need to go to the Google Classroom and find the Google Doc that I've already made. It's got the driving question in it already. It's got the sentence starters in it already. So all you have to do is finish off the answers. Now, you can do that on your phone if you've got Google Docs installed. If you want to edit it on your phone, you will need to download the Google Doc app. Okay. You can do that on Android or on iOS, but get that document open because it's got most of what you need and you just need to finish off the answers. Okay, so we're going to work our way through describe, explain, use, combine. They are color coded, orange, green, yellow, and blue, like in lessons in school. And these instructions are in the Google Doc. So are these starters. So pause this video and then you can go to the Google Doc and you can use the information in that in order to complete the written work. Okay. So I'm going to stop talking. Then in a few seconds' time, the answers will begin. You can come back to this after you've done the written work, check your answers against the answers that are coming up in a moment in the video. But this is the most important work for the lesson. Complete this work. Do it in that Google Doc, and then that will help you keep on track with your learning. Remember, when it says use data, use numbers from the graphs, and use the numbers that you've added into this table here. Okay, go for it. Get your written work done. Right, here come the answers. So use these answers to check what you've written in your Google Doc. If you've made a mistake, change it. If you've totally missed out some important detail, just add it in. Make sure you write the sentence, "Today I have achieved," at the bottom. Okay, these statements are in the Google Doc, so you can look at that to help you decide today I have achieved. Here come the answers. Nitrogen N2 78%, oxygen O2 20%, argon AR 1%, carbon dioxide CO2 0.04%. The Earth is 4.6 billion years old, but the atmosphere has only had these percentages for the last 200 million years. A pie chart is suitable for percentages because a circle can represent the whole total of 100%. Each slice of the pie is drawn to scale so the percentages add up to 100%. It helps us visually compare the size of each slice of the pie. Okay, Mars and Earth both contain nitrogen, oxygen, argon, and carbon dioxide. All four of those gases appear on the pie chart, but we get the marks for using the numbers. Percentage of argon is similar to Earth because Mars is 1.6%, Earth is 1%. They are similar. The percentage of CO2 is very different. On Earth it is only 0.04%, but on Mars it is 95%. The percentage of nitrogen is very different. On Earth it is 78%, but on Mars it is only 3%. The percentage of O2 is very different. On Earth it is 18%, but on Mars it is only 3%. You get the marks for including all the numbers. Scientists believe Earth's early atmosphere was similar to how Mars is today. Because there is no life on Mars, no oceans, this could be similar to how Earth was billions of years ago. We use planets like Mars as evidence for what Earth's early atmosphere was like because there was very little evidence left on Earth to tell us what the atmosphere was like 4.6 billion years ago. Any gases that might have been trapped in rocks in the Earth's crust are difficult to find because the Earth's crust has changed too much through the movement of tectonic plates over billions of years. Make sure you have completed Today I Achieved. It's really important to keep track of how you're doing and what sort of level of understanding you're getting. We want as many students as possible to be achieving grades 5 and 6s, so it's important to get good at the yellow level, using your understanding to explain a science situation in more detail. So please do make sure you've at least done describe, explain and use, and hopefully you might have at least tried combine as the challenge level for this lesson. You now need to go back to Google Classroom, click on the Classwork tab and mark as done for the video lesson. There is a short multiple choice quiz for lesson 1. That's really important so that we can check your understanding. We're going to use that to plan an improvement lesson later on in the topic. So will be checking that you have submitted what you need to submit. So you don't need to submit your Google Doc. Just click mark as done on the video lesson and complete the short quiz for lesson 1. Thank you very much, Year 9 and Year 10. Well done for your work today. And we'll be doing this again for lesson 2. Thank you very much.